Greetings, Pixel Pioneers. It's a pleasure to have you back on my channel. In our last encounter, I had the privilege of guiding you through the seamless installation process of Stable Diffusion 1.5, a milestone that has set us on a path to endless creative possibilities. Today marks the commencement of a new chapter in our digital exploration. We're not just going to skim the surface, we're diving deep into the heart of image generation, harnessing the power of Stable Diffusion to breathe life into your creative visions. I'm thrilled to walk you through the different settings, ensuring you have a solid grasp of the tool that is going to be your brush in the vast canvas of imagination. The spotlight today will be on text-to-image conversion, a feature that stands as a bridge between our words and visual expressions. So gather around digital explorers as we venture forth into the realms of creativity, embarking on a journey to generate our very first images with Stable Diffusion 1.5. Your adventure in visually storytelling begins right now. Today, we're focusing on the text-to-image tab. So I will explain everything important based on an example. Let's first have a look at the upper left, the checkpoint models. These are the pre-trained Stable Diffusion weights for generating a particular style of image. Think about it in that way. What kind of images a model generates depends on the trained data. So a model won't be able to generate animals if the model has never been trained on animals. Likewise, if you only train a model with animals, it will not generate cars or people or objects or environments. So therefore, be aware of what you're trying to prompt, what you're trying to generate, and choose the right model. So a good source for me is really the Civitai page, so civitai.com. Here you find a lot of Stable Diffusion models. You can even go to the specific categories from character to style, celebrity, concept, base model, tool, buildings, vehicles, and so on and so forth. So I'm very much a fan of Protogene. It's very much photorealistic. I'm also like Dreamshaper. That's a good combination between anime style and photorealism. And I also very much in love with realistic vision. So those three I normally use in combination. That provides fairly good results. Today, in our case, we will go with the Dreamshaper 8 version. The prompt actually describes what you want to see in your image. As said before, we're just doing it as an example, therefore we are now just prompting. I want to see a deep forest. It should have big trees. I would love to see some sort of a path in there. A small path with sand and cobblestones. I think additionally we want to see green grass and rocks. Before we start to generate something, let's just go through the rest of the settings. The next thing in line is the sampling method. The sampling method is the algorithm for the denoising process. To produce an image, Stable Diffusion first generates a completely random image in the latent space, and the denoiser predictor then estimates the noise of the image. The predicted noise is then subtracted from the image, and that is happening a dozen times. In the end, you get a clean image. You can see that on the example here. The denoising process is called sampling method because Stable Diffusion generates a new sample image in every step. There's a lot of different sampling methods available. There are old school solvers like Euler or Hoyne or LMS. There are DBM solvers, some sort of a newer generation released in 2022. And there's a new sampler called UniPC, which was released in 2023. Also very important. Next, you need to understand what converge means in that context. So my personal desire, for example, is to create images that are reproducible and look identical in low as well as in high sampling steps. So I just want to feel my images are getting better, more accurate, or more detailed when increasing the sampling steps. And you can see this actually here. That is converge. The image stays the same, but it somehow improves over time. A non-converging sampling method means you get a high quality image, but your results will vary depending on the amount of sampling steps, since every sampling step somehow, some way is changing the appearance of the image, especially when going in bigger steps. So have a look here as well. You noticed how the appearance is changing quite a lot throughout the process? In short, if you like your image and you want to increase the sampling steps, you might end up with a different image, and therefore it is not converging. Hence, I personally prefer converging methods. So please be aware, every sampling method in the drop-down menu highlighted with an A is an essential method and definitely not converge. You can use Euler, or my preference goes towards the UniPC for final image generation. In this case here, I'm now just going with the DBM fast, which is not very well convergible, but it provides fast results, and in that case enough for what we want to present here. Let's go to the sampling steps. This means the number of sampling steps for the denoising process. Higher values typically yield better results, but beyond 50, the additional time required for rendering the extra samples doesn't really justify the marginal improvements anymore. I usually opt for a range between 20 to 50, finding it to be a satisfactory balance between quality and efficiency. Be cautious, as the images may undergo significant changes if you select a non-converging method while altering the sampling steps. Therefore, for the sake of predictability on consistent results, it's advisable to choose a well-converging sampling method such as Euler or UniPC. In that case, we're going now with the standard of 20. We want to have quick results. Next is the width and height of the images. That is literally the resolution you can define. So we're going here with 1024 by 512. The CFG scale, that means classifier free guidance scale, and it means the parameter to control how much the model is considering your prompt. Think about it that 1, it would almost ignore what you have prompted, and with 30, it would strictly follow your order. Too strict order does not necessarily make your images better. Try to aim for a good rhythm between the freedom for AI to generate what it believes is right and the integration of your prompts. In our case, we will go with a tree. So let's talk about the high resolution fix. This option applies an upscaler to your image. You need this because the native resolution of Stable Diffusion is rather limited. So I get it. Okay, at the end, your limit is your hardware. But to avoid running out of memory, upscaler is always a good solution to increase your image size. So whenever you have developed your image, you're ready to go for the final version, just head into the high resolution fix, go to upscale, change your multiplicator, and you're ready to go. In that particular case, I have an upscale by 2. You see my original size of 1024 by 512, and my output is doubled. In our case, I'm going down with 1 because for presentation purposes, I don't want to have an upscaler in place. Important as well is also the algorithm you want to use to upscale. You will find under upscaler the different versions available. So I personally love to go with that version. It actually means enhanced super resolution generative adversarial network. That version is a very good AI upscaler. You have the version with the R at the beginning. This is the enhanced version of it. And you have another version that is more for some sort of anim style. You have a lot of different algorithms. When going through the 3 different versions I just described before, they're serving a different purpose. So when you have as an output some sort of an anim style that requires a different algorithm than if you would have tried to recreate some sort of photograph. So therefore you have those different versions. All the three I mentioned before are rather good to go with. The last in line is the refiner. As I just said before, you have your stable diffusion checkpoints here. And the refiner allows you, while generating the image, to combine this with another model. We're now here going with the Dream Shaper 8, but if I want to combine this with, for example, the Realistic Vision, I can just enter it in here and switch at means at what point in time while generating my image, the second checkpoint, the second model kicks in. In that case, it kicks in at 0.8 of finalization. Now that we have covered the most important options and possibilities, we could actually start to generate our first image. So here we are. Our first image is being generated. We have obviously a deep forest. We have big trees. We have a small path with sand and cobblestones. We have green grass, quite a lot actually, and we have rocks. So I think even though the CFG scale is at 3 only, we have incorporated all our prompts into the image. Let's have a look at the canvas here. You have your image in and a lot of informations. You will find your prompt, the steps, CFG scale, the seed number, and then all the other information that are important to reproduce that kind of image. You need to understand that the seed number here allows you to reproduce the exact image over and over again. So right now it's at -1. It actually means the system decides, but it always provides you the seed number. So if you ever want to reproduce that image, you have to take the information here, enter it again into the system, and you will reproduce the same image. But it is important that you also use the same size, the same scaler, the same sampler, because that is very important. So the number here defines the exact image in combination with all those settings that you have set before. Let's talk about batch count and batch size. So this is about the number of images that will be generated each and every time. So you might know from Midjourney, when you generate an image, you always get presented by 4 different suggestions. And you could actually do the same here. So that's why on batch count and batch size, you can decide on the amount of images. The difference between both is actually rather simple. While batch count is actually rendering your images one after the other, batch size is rendering the amount of images at the same time. So that means with batch size, you multiply your compute power by the amount of images that you want to render, while on batch count, it has no influence on your VRAM or general performance, because every image is rendered separately. So if you want to be presented with more than one option and you have a low VRAM, I would suggest you stick to the batch count. Let me just present that to you. We're going with a batch count of 2. So I went with a batch count of 2. Both of the images are presented to me next to each other. I can now select each and every image separately. And important for you, what we just discussed before, you will find under each and every image the information you need in order to reproduce that image. Let's have a look again at both of the images. I like the first one actually very much. So let's go with that version. You can copy and paste seed in here. Go back to your batch count of 1. And if you would now just hit the generate button, you would generate exactly that image again. Let's just do that for demonstration purposes. And here's the image. Imagine I want to improve my image now. The next step would normally be to say, okay, I want to increase my sampling steps. Like we just discussed before, to get a bit more details, get a bit more accurate, all that kind of things. You remember what we just discussed before? The converge versus the non-converging method. In that very precise case, we're working with DBM fast, and DBM fast is not very well convergible. So that actually means if I'm now going into the sampling steps and I'm changing it from 20 to 40, in the anticipation of creating just a better image that has a similar look, I'm getting very much disappointed. Because what will happen is that most likely I will get a new image. I changed my sampling steps to 40. I have changed nothing else. And I'm now hitting generate. Have a look at the result. This is related to the non-converging method. The image is not the same. So if you compare now both images with each other, one with the sampling steps of 20 and the other with the sampling steps of 40, you will see a very big difference in the overall appearance of the images. Although we're still using the same sampling method and the only thing we changed is the sampling steps from 20 to 40, you get a complete different image. And once more, this is because you have a non-converging method. And now let's just go through the same procedure, but using this time a well-converging method. So we're going from DBM Fast to UniPC. We're going to a sampling step of 20 to have a good comparison to the DBM Fast. We don't change anything else and we hit the render button. The image that will be created now looks different than the one before. That's because you're using a complete different sampling method. So now you have your image created with the sampling method of UniPC and the sampling steps of 20. But the benefit is now, if you like the image, you can now increase the quality, changing the sampling steps to 40, hitting generate again, and you will still have the same image. Ideally, due to the amount of sampling steps, you have now an image that has the same appearance, but it might have a bit more detail, it might have more accuracy, but overall it is the same image. And that is because I have a well-converging method. The image stays the same throughout the process. For consistency, I'm just jumping back to DBM Fast, changing my sampling steps to 20. I haven't changed the seed. And if I hit now generate, I'm back at my former result. So let's continue here. So let's talk about negative prompts. If we look at the image, at the moment, we have said a deep forest, big trees, a small path with sand and cobblestones, green grass and rocks. The good thing is that this green grass could also be interpreted as moss. Let's just say as a negative prompt, moss layer. In theory, into the negative prompt, you could enter everything that you don't want to have in the image. In our case, we say we don't want to have moss in here. So you see now moss is being replaced with plants and bushes. So I think that worked very well. And yet you have the big trees in, you have the path and all that there. Let's just take this away again and go back to the original image. And you see, I have generated the image again, but since I have the same seed number in, I generated the same image again. So that's fantastic. That's why seed is your friend. If you're once happy with an image and you want to first develop it, do it here and make sure you keep the seed number. Let's just take another negative prompt. So we have a couple of bigger rocks here underneath that we want to take away. So we just say bigger rocks, plain and simple. Now the rocks are completely gone, replaced with grass and plants. And I think also it's a very nice composition. You have still the path in here, you have the trees. So I think it's a beautiful forest scene. So let's jump to one of the last options we have. You can actually combine two seed images with each other. In order to do so, let's quickly simplify the scene. We deleted the negative prompt. We changed the seed to 10. Quickly generate an image. And this is how the image looks at 10. Okay, so you have two paths inside. You have the light coming more from the left side. You need to know when I now start rendering, I generate two images based on my batch count of 2. The good thing is that if you have a fixed seed number, the second images that will be generated is automatically the 11. If you would have third images, it would be 12, 13, 14, 15, and so on and so forth. You see that the first image has the seed number of 10, while the second has the seed number of 11. Let's have a look at the second image. You have just one path you have similar kind of trees and look and feel overall, but you have the light coming from the right upper side. And you have a little bit of a small hill here on the right side. If you want to combine now those two images with each other, you can actually do that. Remember 10 and 11. In seed, you can here check mark this extra, and then you have the seed of 10, and the variation seed, you enter 11 for the second image. You have the variation strength. Here you decide between the first and the second image. Let's just go with something in between. And if you would now hit the render button or generate button to be more precise, you see now a combination of both images. Have a look. You have two paths inside. You have from the first image somehow the light coming from the left. And on the second image, you have the same kind of trees. You have the path. You have the light somehow coming from the right side. So you have now combined those two images and in theory have the best of both. This is absolutely up to you. And again, you can go with the variation speed to your liking. Have fun with it. So now you know how to combine two images with each other. But imagine you have a very precise area within that picture that you would like to change. There's almost no way to get that very specific area changed based on the prompts that you have to enter here. There's another method. And in order to do so, you just go to the image, and here on the bottom you find this little button, Send Image and Generation Parameters to Image in Paint tab. You click on that. Automatically, your image is being sent to the Image tab. It's being incorporated, and you can start to paint now the very specific areas. Let's just go to this pencil, make it a bit bigger, and then we're painting over here. I want to have rocks covered with moss in that very specific areas here. I want to have it here, and I want to have it here. So there are a couple of things that we need to change. In the in-painting area, you change only mask. You change the sampling mode to DPM fast. Again, this is by far not the best sampling method. You have to take Euler if you want to go to your final image. But I think for this purpose here, this is more than fine. The CFG scale, important, also go down with a similar size than what you have in your original image. And the seed can stay at 10. You have painted the areas. You have set that you only want to have the mask areas changed. Now it's time to go to your image-to-image prompt, and you can now say rocks covered with moss. You see on the right side, fantastic. The areas that you have highlighted here on the left covered with rocks and with moss on top of that. As we wrap up our discussion on Stable Diffusion, we have taken a good look on how images are generated. We explored different settings and we learned about the key sampling methods. We also touched on the cool feature of in-painting. All these steps have given us a better understanding on how Stable Diffusion works. If you enjoyed this journey and are excited for more, make sure to hit subscribe, like, and ring the bell so you won't miss out on more awesome content like this. Your support encourages me to keep diving into exciting topics and sharing my discoveries with you. So until next time, keep exploring and learning.